Yeah. It's okay. It's okay now. Thank you.
Let's get started. Yeah. Okay, welcome to MPLS in Madrid, and usual housekeeping to be done. Note well, so we're early in the IETF week. You need to be aware that anything you say or do is a contribution and is subject to the BCPs. If you're not familiar with them, please go away and read them. Lack of familiarity will not be taken as an excuse. Normal administration, the thing to call out here is the meeting minutes. Please contribute to them as we go along. Make sure anything you say is reflected accurately. Agenda. It's a very tight agenda this time. We will try to hold everybody to that. Any comments about the agenda? Silence means we go on. So, no errata, that's great. No in or outgoing liaisons. Documents, we have 6, yes, count them, 6 RFCs since last time. Tony and I are really pleased because we get paid for every RFC. Tarek doesn't get paid because he's not here. And we have one more document in the RFC editor queue. I think that will just progress as normal. Two new, I don't know what my screen just did then, two new documents into the working group since Bangkok, the M&A header and the M&A NRP selector. We obviously need to be working on those. And then one working group document updated, and that's next on the agenda, and a couple of others in progress. The M&A header hasn't updated since last time, but there is some backwards and forwards on the list describing the current issues and the resolutions and expecting a new revision soon. So hoping that will move forward.
Actually, sorry, Adrian, to interrupt you on that. This is Tarek, and as Shepherd, there was an update, Shepherd, of this document that you're talking about, M&A-HDR. There was an update posted over the weekend, and I reached out to one of the authors, and he's willing to give us a 30-second glimpse of what they posted, if it's okay.
Yeah, that would be useful. Who's that and where are they?
They're in the queue, and I think that's Rakesh.
Oh, go for it, Rakesh.
Rakesh Gandhi from Cisco Systems. We had exchanged a few emails on the mailing list. So we went through various discussions and issues on the list over the last 3 months or so, and we shared proposed changes with the updated draft, I think about 2 weeks ago. We received some feedback on those changes, and we shared the revised changes last week. And as we had mentioned, we have now posted a new revision yesterday that addresses all the known feedbacks, and we welcome your further review and feedback. Thank you.
Thank you. So from your point of view, is this ready?
It is ready.
Right. Anybody in the room or virtually in the room want to disagree with that now? Okay, that's great. So Tarek as Shepherd will look at the next step on that. Thank you.
Okay. Thank you. One more comment since I'm here. On the previous slide, on the PS M&A header,
oops, wherever it is.
One before that, maybe 11. Yeah. So there is no, so PSMNA header is a dead working group document. It's actually MNA PS header.
Haha, thank you. A bunch of new individual documents this time round, and they find themselves on the agenda. And one of the existing individual documents comes up this time. With all those individual documents, please make sure you talk to the mailing list about what's going on and what you want to see happen next. Right. So next up is the MLDP Yang document.
Okay, thank you everyone. My name is Kamran. I am presenting an update on MLDP Yang on behalf of authors. Just a quick recap before we go through a quick history. First of all, this is a late introduction to the late intro to the agenda. Appreciated, chairs to accommodate this request. So just in 5 minutes, I'll try to cover a quick update on Yang model. This model, augments LDP Yang, which is already an RFC. And it's a work-centric model with covering both V4 and V6 address family, but it does not cover any applications that run on top of MLDP, nor the O&M procedures at all. And it basically consists of two main modules. One is a base module, and the other is an extended module, which means base is the fundamental LDP and MLDP constructs and features that needs to be covered. Extended are more advanced cases. And this model conforms to the NMDA architecture. Just quickly, current status has been working group document for a long time. We had just posted revision 13 just before IETF 123. It has been going through routing director early review, quite a bit of back and forth with Jeffrey for his great detailed review. Right now, model does not have any Yang errors or warnings. In terms of implementation status, couple of vendors, including Cisco and Ciena and a few others, they have at least partially implemented part of this model. So in terms of history, as a reminder, we had presented this long time ago in IETF 111. It was a virtual presentation during COVID. It was revision 8. Right now we're sitting on revision 13. In terms of the reviews, it has went through quite significant round of reviews with Yang Doctor's early review by AC, Lindam, and then another review by Joe Clark on version 11. And right now it's going through routing director early review by Jeffrey. We have closed all other reviews except last couple of comments from Jeffrey that we plan to close during the ITF. In terms of changes since last time this was presented, all of these 5 versions, there are 3 major updates. Version 10 aligned this MLDP Yang draft with LDP RFC comments, because this was a augmentation and a split document from LDP Yang. Initially, LDP and MLDP Yang were the same document, so it inherited inherited similar challenges or issues that LDP Yang had. So all the comments that were provided as part of LDP Yang becoming RFC, we had to port all those comments to MLDP Yang. So version 10 addressed all those changes. Then the other significant changes that happened was in version 12. That was for the Yang Doctor's review number 2 by Joe Clark. And the version 13 also addressed added few changes as part of the routing director early review. Do not want to go through this, but just a quick flash that literally what it's trying to show is that MLDP is augmentation to LDP. It covers both V4, V6 address families, capabilities, bindings. All of that is pretty much fundamental building blocks that's coming from LDP Yang. It has its own feature set, which is summarized here, all capabilities of MLDP and whatnot. It covers quite a comprehensive set of MLDP features. And the last bit that we are trying to finalize and close with Jeffrey is a recursive fact. After that, we are, we are confident this document is, I think, ready to progress further. It also covers notification, which I'll skip. So next step, as I mentioned earlier, that literally right now is the routing director early review. Comments have been addressed. We posted version 13 so we can present in ITF, although we still have 2 pending comments. So we will close this and push an update. After pushing this update, we are looking to request a working group last call on this document. That's all. Any questions, comments?
So thanks for talking about this and for pushing the revision. When you do the next update, obviously you've got that company affiliation to fix.
Yeah.
Also, can you make sure ID NITs is clean? There are Yang models are a real pain with ID NITs because of line lengths and things like that. But,
yeah, that was part of version 10, but we will definitely do one more round of it. Yeah. Thank you.
Tarek, you're in the queue.
Yes, hi, Tarek. As shepherd of this document as well. Kamran, I noticed there were back and forth discussions on a couple of comments. Maybe they were controversial or not. You might want to involve the working group on those if you feel they are controversial. And there was mention of a meeting with the reviewer. I may have not captured if you said that the meeting happened or not.
Okay, so, yeah, sorry, go ahead.
Nothing from my side. That's it.
Okay,
Thanks.
so I think about the comments I mentioned, those are mostly recursive effect related. I don't find them controversial. I think I'm still trying to finalize those. If there's anything that we find we need a working group, input, we'll definitely share with a wider list. In terms of the meeting, I think just saying that we'll be meeting with Jeffrey in person during ITF to close last couple of points regarding recursive effect. How do we model this in the current model is, I think, what we are debating. And but the construct that are coming are not controversial. They're coming from the base MLDP specs. It's just that how we are modeling. That's the discussion.
Okay. Yeah, thanks for that. And there was another discussion point on opaque data. Should it be interpreted or not? Yeah, I'm not sure if that was closed or not.
You're right, but that's kind of part of the recursive as well. In recursive, definitely opaque means opaque. So yeah, these 2 points, you're right. They're related, but I didn't mention opaque. Opaque is also kind of related, and we'll discuss and close.
Lovely, thank you.
Right, thank you.
Okay, hello everyone. It's Jane Song from ZTE. I'm behalf of the co-authors to present this draft. Actually, this draft has been presented for several times. During the 150th meeting, 180th meeting, and the 120th meeting. And because this draft is mainly to address the MPLS M&A support for deterministic latency. So the MPLS working group is the main working group here for this draft. But because it also involves the deterministic latency information carried in the document, so it also needs other dependencies with the .NET working group drafts. During last meeting, um, not last meeting, last presentation, during the 120th meeting, it was first presented at MPLS working group. And what the feedback received is that the draft is in the right the working group and suggest to socializing the use case with the networking group. And the feedback from .NET working group, actually we then, after the working group, MPLS working group presentation, we also presented and the .NET working group the feedback from the chair that I think they believe the use case necessity, but still think it's a little early to design the MPLS support for the deterministic latency because they are still working in the taxonomy draft. Taxonomy is mainly for the queuing my service summary, but it has not began to develop the queuing encapsulation. So for this meeting, we may need to share the draft updates and share the feedback from the .NET working group. The updates for this draft, we followed the two main points. First is to improve the scalability to support the aggregation flow identification, and the second one is to bring the simplicity to the data encapsulation. And always this draft follows the requirements specified at the .NET, this working group draft scaling requirements. First one to support the aggregated flow identifications, as the second one to support the information may involve the deterministic latency. This figure showed the encapsulation for MPLS for deterministic latency support. The left figure shows the MPLS .NET encapsulation, and the red color showed the the MNA label, and the RNA opcode is added, and this information be carried in the MPLS MNA opcode, and the traditional F label, S label, and .NET control word was kept in MPLS label stack. And for the latency data, we removed the queuing method field because we think queuing method may be selected by the .NET control plane. And the queuing method, specific information to the queuing method should be carried in the data plane is uncertain. And for the next steps for this draft, we will still to follow the progress of .NET working group, to make the corresponding updates to the, by the requirements and the taxonomy drafts and review and suggestions from the working group. Thank you.
Okay, thanks. Quick chance for questions. No, okay, thank you. So next up is Fabian, who has three in a row. Just waiting for.
Can I actually remove this, or is it fixed?
You can rip it out, yeah.
You should be able to pull it straight. Can you hear me? Does it work? Yes.
You're in the process of sharing, Tony. Yeah. you have to do the clicker thing. So you go to the attendees. And the top one, yeah. Everything's got to be in the right order. So it'll let me do it. Right, that's what you were hoping for. Should work.
Okay, great, thanks. So Fabian from University of Tübingen. I have actually 3 talks. The first one is about signaling M&A capabilities using IGP. So quick motivation. Currently, the MPLS M&A header draft says that the node responsible for selecting a path through the MPLS network needs to know and consider the M&A capabilities of the transit nodes. Further, the draft also says that the mechanism by which the capabilities of the nodes are known are out of scope, and something similar is written in the RFC on the M&A framework. So 2 questions behind this draft: what exactly are the M&A capabilities? We already defined the RLD, the readable label depth, in the framework RFC, and I will talk now about the NAS MLD and opcodes, which we should signal. And second question is, how should they be signaled? So what should be signaled? NAS sizes in hardware. So from the instack draft, currently a NAS is up to 17 LSEs large. That's a result of the encoding. Now, if we are doing hardware implementations, or at least that's my experience of our hardware implementation, LSRs must reserve memory in arrays to parse maximum sized NAS. So big important thing here is, in hardware, at least in my experience, we do not just have a big stack of LSEs with the size of RLD, but instead we have a stack of differently encoded LSEs in different arrays. And as usual with arrays, they have a fixed size, which is allocated prior to runtime and cannot be changed dynamically. So that means we have to allocate 34 LSEs for 2 maximum sized NAS if we are doing select and HBH scope NAS at a LSR. And we have to do this even if our packets only contain a minimum sized NAS. So even if we're only processing a single network action, we still have to reserve memory. As a result, the maximum sized NAS drastically increased the required RLD in doing M&A. So therefore, back in Dublin, I described or proposed to reduce the maximum supported NAS size in LSRs based on the available hardware resources, because that allows us to reduce the number or the amount of resources we have to allocate in LSRs, but we have to signal this to the ingress, because otherwise the ingress may push a NAS that is too large for a node to the stack, and that would break forwarding or M&A even. Therefore, in this draft, we design the scope-specific NAS sizes, the NAS MLD, which is the maximum label depth. It's basically a concept similar to the maximum segment depth, but we just renamed it for the context of NAS, and it's not only related to segment routing. And this parameter describes the maximum number of LSEs in a NAS, including the format A, B, C, and D LSEs. So for example, very trivial here, you can see the blue select scope NAS, which is 4 LSEs, therefore the MLD is 4. The maximum MLD for this is 4. Okay, just for completeness, we also have to signal supported opcodes. And for now in the draft, I said that if a network action opcode is not signaled, we assume that it's not supported by the node. It's pretty straightforward. So next question, how do we signal? I will go very briefly over this. It's basically just using existing mechanisms. We can use node and link specific ISIS advertisement using existing sub-TLVs. I won't go into detail. Basically, we just have a sub-TLV with now newly introduced NAS MLD type fields. They are registered or requested by the IANA consideration section of this document. And the MLD value is for now a number in the range of 2 to 17, because that's the minimum and maximum size. But maybe we could also shift this to be 0 to 15, but that's just definition. Yes, The same applies to OSPF, the same concept. It's just different TLVs, like different type fields, but we still reuse existing sub-TLVs, and yeah, the concept is the same. So we again have the NAS MLD type and the NAS MLD value, just a different sub-TLV. Okay, security considerations apply from the M&A header draft and from those two RFCs listed here. That's the ISIS and OSPF signaling, or the sub-TLV. And IANA considerations request the allocation of IGP MSD type entries in the registry for the 3 different MLD values for each scope of the NAS. So next steps and summary. First of all, what do we want to signal? The RLD, the maximum size of NAS per scope, and the available opcodes. How do we signal? With link and node-specific ISIS or OSPF sub-TLVs. And next steps are, how do we signal supported opcodes? Because I think using the sub-TLV might be a bit inefficient for support or for signaling a list of opcodes. Then I only talked about in-stack data, so what parameters are required for post-stack data. But I think right now there are too many open discussions about the PSD solution, so we cannot define the signaling at the moment. And since it's a pretty basic draft, I'm also looking for collaborators or co-authors on this. So thanks for your time. We may have time for one question because I have 3 talks, so we may have a bigger question section at the end if we still have time.
Right, fine. Yeah, you manage your time. The clock is showing your whole.
Yeah, so one question. First one.
So I'm going to grab it. So Jim Guichard, the thing that immediately jumped out is the encoding. That probably needs to go to LSR, right?
You mean the header encoding, or which
Yeah,
encoding?
because you're basically defining stuff for ISIS, which is that really needs to be done in LSR, so, or at least liaise with LSR. So I'm assuming you talk to the chairs to figure that out, but obviously I don't want anything done that's going to be not understood by LSR.
Yeah, thanks for the feedback.
Sorry, Matthew Boccinocchio. I just want to very quickly make a point.
Okay.
The capabilities and readable label stack depth, or MRLD, are not quite the same thing. So we've always separated that in the past for entropy label, for example.
Mm-hmm.
So maybe that we should separately. And second question is the capability to accept the BSPL and not discard it if you don't recognize it, for example, is different from the capability to support particular opcodes. And I didn't see anything in the draft about, do I support M&A at all as an advertisement? Because if you send traffic to a node and you expose that BSPL and it doesn't understand that BSPL, it needs to discard it. So it's quite important to be able to signal that.
Yes, that's a good point.
And third, I think we also need an inter-domain solution, not just a single domain solution for the IGP. So for example, signaling in RS3P is what we've done in the past.
Yeah. Yeah. So that's a good point for the future to talk about what other stuff do we need. It's just the first version, actually. Yes, if you're very quick, we can have one more.
I'll try to be quick. Greg Mirsky, Ericsson. It seems that this information is not dynamic. So if it's not dynamic, maybe doing for the IGP is not a good idea because that's refreshes and we are populating LSDB. So maybe to use something from the Yang because it's a configuration rather than that, and then argument it with something that based on LSP ping to do their on-path discovery, collecting information about capabilities. And for what Jim suggested is, since we want to have the same values and ISIS is more restrictive, so use the same size of their if doing IGP-based capability advertisements. So there is no need to do 16 bits for the capability if ISIS can advertise only 8-bit space.
Yes. Thanks. Okay. Then I will go directly to the next talk, which is about the MPLS network action for stack management. Quick motivation. So with M&A, the required RLD and LSRs is actually very large compared to traditional MPLS. Why is that? First of all, we have 34 LSEs for NAS from the IETF draft, which you may reduce with the signaling approach from my previous talk. And the second part is that we must parse the so-called in-between stack. What is that? First of all, from the protocol design, the HB8 scope NAS may be located somewhere deeper in the stack because of RLD constraints. So it's not directly at the top. That's the result of the protocol design right now. So the problem is if we have a hardware node that starts parsing from the top of stack and goes down to the bottom of stack and just reads until it finds the HBH NAS, we cannot just throw away the labels we parse until we find the HBH NAS, but we have to store it somewhere. Therefore, we have to parse it, we have to store it, and we have to allocate resources for that. That increases the required RLD also in nodes. As a result, we could say we want to eliminate the in-between stack by placing the HBH scope NAS at the top, then we always find it directly, but it would get popped during forwarding, and therefore we require many HBH copies in the stack. So therefore, it would still be better to keep the HBH NAS at the top because that avoids parsing relevant LSEs, but we have to preserve the NAS somehow, and that's why we propose the HBH preservation mechanism. Basically, we constrain the location of the HBH NAS to be close to the top, like below the top of stack forwarding label. And then we reorder the stack during forwarding, meaning if the top label is popped, we bring one label from below the NAS to the top. And this way the NAS is not exposed. And we also never require HBH copies. So LSRs are required to perform this operation. And how can we indicate this? Now, if only we had a framework to instruct LSRs with network actions. Fortunately, we are in MPLS and MNA, so we introduced the stack management network action. And this is the actual topic of this draft. So it's a new network action or an opcode with for now 2 operations, which are indicated in the AD. We have a move N operation, which moves a number of LSEs from below the NAS to the top of stack, which we can use for the HBH preservation. And we have a second operation, pop N LSEs, which pops a number of LSEs below the NAS. That's used for stateless MNA-based egress protection, but that's a topic for the next talk. The network action is not tied to those use cases, so those are just 2 examples, but it's rather meant to be kind of a general mechanism for stack management. And the encoding is for now, like you see here on the slides, it can be encoded in either format B or format C. And we have 4-bit for the move N and for the pop N operation. Okay, how does it work for HBH preservation? Basically, we use the stack management network action to move a number of LSEs to the top. So it's added by the ingress LER in the HBH scope NAS with move N equals to 1. And if a node pops the top of stack label, that means it has to move 1 label to the top. So therefore, the HBH NAS is preserved and we reorder the stack. A problem with this mechanism is that we have many MPLS legacy nodes in the network that may not support this and therefore are not aware of the move-in operation and may expose such a NAS to the top because the label is not moved. We can solve this by instructing the preceding LSR of an MNA incapable node to bring more than 1 label to the top, namely as many labels as popped on the path of incapable nodes. So in this example here, we have a network path with 2 MNA incapable nodes in between. Each node removes 1 label in this configuration. So therefore, the preceding MNA capable node is instructed with a select scope move N operation here of 2 labels and 1 for the general mechanism in the HBH NAS with 1 label. So in total, we move 3 labels to the top. Each node on the path pops 1 label and still the HBH NAS is never exposed, but always close to the top. Okay, quick discussion. I'm not only talking about this concept, but we also have a proof of concept implementation in P4 on our hardware target. So we extended the existing MNA framework implementation with this network action. There we achieved line rate processing at 400 gigabit per second per port. And we tested it with the network topology from the previous slide. So with this one, but it's actually not dependent on the topology. I mean, if it runs at line rate, it runs at line rate. A downside with this mechanism is that it doesn't work on legacy hardware like push, pop, or swap hardware, but those nodes are most likely not capable of MNA anyway, and we have the mechanism for backward compatibility, so we can just skip those if we have one preceding MNA node. The effect on the required RLD is that we do not have to parse an in-between stack anymore, which means we don't have to waste resources for parsing in hardware. We don't have HBH copies anymore, which reduces the overall stack size. And also if we have to do updates to the HBH NAS, we only have one position in the stack where we have to do these updates. The minimum required RLD is now 35 plus n LSEs, where n greater than 0 is the number of LSEs that we need to bring to the top at once, so at least one if we have a greenfield network. And as a result, since the required RLD is reduced, we may also integrate nodes with a smaller overall RLD in MNA. So maybe legacy nodes with some more processing power. Okay, security considerations from the MNA header draft apply to this document, and IENA considerations are the allocation of a new network action opcode in the stack management registry. Summary, I introduced the MPLS network action for stack management, which features move-n and pop-n operations. Also, more operations may be added in the future if you have ideas. I don't know, maybe a swap-n operation, but I have no use case for that, but it's up to you. So the network action is not tied to a specific use case. We can use it for various applications, for example, the proposed HPH preservation or SMAP, which is topic of the next talk. And the mechanism reduces the required RLD using the proposed action by reorganizing the MPLS stack. Yes, also note that for this mechanism, actual no changes in the MNA drafts are required. It's just applying the new network action. It works with the existing framework and header drafts. We have a P4 implementation ready with this. And if you're interested in that topic, I also published a paper at the ACM IETF Applied Network Research workshop, which I will present tomorrow, 5 p.m. here in Madrid. So there's also a link to the program and a link to the paper. If you're interested, you can check it out. Next steps are discussion, but maybe on the mailing list, since time is a bit limited. More use cases, more operations, maybe swap-n or whatever. Thoughts about the HPH preservation, maybe also from an operator side, if that's feasible to do or not. Precedence of operations is also a question, what do we do if we have move-n and pop-n at the same time in a NAS, or should this even be allowed? Yes, I'm looking for collaborators on this draft, so feel free to join in, and feedback is always welcome. So thanks for your time. I see nobody in the queue, which is good, because time is tight. Good, then finally for my last talk about stateless MNA-based egress protection, short SMAP. I already proposed this concept back in Dublin, just here as a recap. We have the MPLS egress protection framework, which establishes bypass tunnels for egress router on an egress failure. That relies on the point of local repair, the PLR, for detecting and actually repairing that. In this framework, the PLR maintains a mapping of transport tunnels to bypass tunnels, which has to be signaled between egress, protector, ingress, and PLR. Stateless MNA-based egress protection now changes this a bit, since we carry the egress bypass tunnel information like rerouting labels in the MPLS stack instead. That means we do not require a mapping of those in the PLR, which is why it's called stateless. And also signaling with the PLR is not required anymore. Instead, the PLR uses the bypass labels from the stack to reroute traffic on an egress failure. Now, since the initial version, something has changed. Back then, we proposed to encode the bypass labels in the ancillary data field of the SMAP network action. This network action is now entirely removed from the draft. Instead, we use the pop-n LSE operation from the stack management draft I just talked about before that. Okay, how does it work? First of all, the ingress node inserts the bypass MPLS labels to reach the protector at the bottom of stack or related to the point of local repair into the MPLS stack. The ingress is most likely involved in signaling, so it knows about those labels or which are required. And further, the ingress inserts a select scope pop-n operation destined for the PLR. So in the stack, we have those bypass labels, and they are preceded with the NAS and the pop-n operation. So behavior, if there's no failure, is pretty straightforward. First of all, we pop the top of stack label and set the egress port accordingly. Then we process the NAS. The pop-n operation is contained in there, so we pop a number of LSEs below that NAS, which are the bypass labels. And since this NAS is exposed to the top, we pop it as well and then just forward to the egress as usual because the stack is basically empty. If there's a failure, the procedure is similar but still different. Again, we pop the top of stack label. We may set the egress port or not, doesn't matter. We process the NAS, and since we detected a failure, we ignore the pop-n action, so no labels are removed. This time, the bypass labels become top of stack because the NAS is exposed to the top and removed as well. And we can set our egress port accordingly or override the egress port since we detected a failure and reroute to the protector node with this. So the resulting stack is just this part, and that's the information we need to route to the protector node. Okay, security considerations, I think nothing changed there. It's still the M&A header draft and the RFC of the egress protection framework. We now don't make any IANA requests anymore. Previously requested an opcode for the SMAP network action. This is now removed from this draft since we don't need it. Next steps are discussion. Is SMAP with pop-n helpful? The last approach with the SMAP action was a bit clunky. Maybe this is better. I want to do a proof of concept implementation of this, maybe in our M&A framework and before, maybe ePPF based or something else. Still, as always, I'm looking for collaborators on this draft, and feedback is welcome as always. So we now have 5 minutes for questions. If you have questions on the previous drafts, they are also welcome.
So Tarek.
Yeah, hi, Tarek, as a working group contributor with Cisco Systems. This mechanism of encoding the bypass labels, does it have to be that the merge point is the egress point, or can the merge point be another transit LSR, for example? Generalize the concept so that the bypass merges back on a transit LSR.
Well, it's actually not tied to only protecting the egress. You may also use it in a generalized way. So the network action itself just states to pop a number of LSEs below the NAS, a generalized concept, but you may use it for other means.
Okay, in that case, I'd suggest to, maybe consider renaming the draft because it's only talking about egress protection.
Yeah, I mean, we have existing mechanisms to do protection of transit nodes. Therefore, I'm not sure if we need it here. But if it shows that it could also work for transit nodes and is more helpful than existing protection mechanisms, we can, of course, change it to a general protection mechanism. It's not currently, you could apply it also to transit nodes.
Joel, go ahead.
If I understood your presentation properly, the processing of the pop-in label, pop-in action, depends on this external condition. In the particular case, there being a failure at the egress. But it doesn't seem that it's encoded in the stack that this is conditional and what condition it is on. And the pop-in is just a generic always pop-in. If we want it to be generic, to be conditional, we need some way, I think, to indicate that it's conditional rather than just using the arbitrary pop-in and then magically knowing, oh, you sometimes pop it and sometimes apply it. Doesn't seem like you can just magically know that.
Yes, that's a good point. And we still have very many reserved bits in the stack management network action, which we could use to indicate that behavior. For example, we could set a single bit that says we want to do pop-n with the SMAP network action or the pop-n network action with SMAP. And then this indicates to the PLR that it has to ignore the network action if there is a failure, for example. That's a good point. Thanks. Okay.
Looks good. Thank you very much.
Hi, I'm Yalu from ZT, and this presentation is about M&A for metadata in SR service programming. So, SR service programming provides data plan functionality required to implement service segments and achieve service programming in both SR MPLS and SRv6 networks. And the metadata provides contextual information about the data packets which traverse the program service path. So, about the encoding of the metadata, for the SRv6 data plan, it is encoded as SIH-TRV objects. And before M&A, the metadata in MPLS data plan coding, there are some works in the past. For example, payload protocol identify label at the bottom stack, and sets with semantics or presence of metadata may be used to indicate the metadata, but there's no standardized mechanism yet. So this document defines MN encoding to carry metadata in SRV service in SR service programming with SR MPLS data plan. So this is M&A in-stack encoding for service metadata. So two types of metadata encoding is defined. The first one is the fixed length service metadata. So the encoding is similar with the NSH metadata type 1, which is defined in IFC 8300. So it is a fixed length metadata field, so no assumption is made of the context of the metadata. And the second is variable length service metadata, so which is similar with the NSHMD type 2. So the metadata field length depends on the value of the network action length. But it should be noticed that although it's called variable length, and also think that the length of the service metadata must not be changed on the fly. So the data plan can, so the device can process it more easily. And the PSD, the post-stack encoding is also provided in the current version. So similarly, so two types of the metadata field is defined, one for the fixed length and one for the variable length. And so I'm not skip the detailed encoding. And it should be very much appreciated if the working group could provide some feedbacks, for example, about the position of the metadata. Should it be in stack or post stack or both? So do we need both? And about the encoding of the metadata. So besides two types of metadata encoding defined in this document now, are other formats required? And welcome feedback, comments, and welcome collaboration. That's all. Thank you.
Doesn't look like we have any questions. This is still quite early work, isn't it? So I'd like people to have a look and discuss it on the list.
Thank you.
We'll get there, Greg.
Hello. So I'm bringing you a new proposal for using M&A to collect information about explicit congestion notification. So it's in combination with the ECN technology that's available in IP and supports their L4S framework. So what's motivation? L4S has been experimented with and demonstrates some encouraging results. RFC 5129 described the mechanism of supporting ECN, but it was at the time when their 3-bit field was still considered to be experimental. So since then, we realized that now we need it for traffic class. So which basically means that if 2 bit positions of TC is used for ECN functionality to really signal support of ECN, and where the packet experienced the congestion situation, so then it does not allow us to do differentiation of the traffic classes with only 1 bit. So what we can do with MNA? There are 2 possibilities to do MNA as instance data. So because it's immutable data, we need to move this field outside of immutable space. So thus, it could be used for format B or format C. Because the format B is mandatory, so there are 2 options. So that operational code could be used in the format B, and format D can be used to carry the ECN information, or operational code in format B can be no operation, and then opcode for ECN can be used in format C. So there are 2 options, and welcome your feedback. Let's do this discussion on the list. There's also in the other option is for ECN to do it as a post-tag data, because so all the space is immutable. The ECN was been placed as here, following the PCNL, so network action length field. So the operation is that if node A is an ingress into MPLS domain, so if it detects that ECN is supported, so whether it's a 0, 1 or 1, 0 in binary, so something not as a 0, 0 in binary, then it installs the ECN MNA, and transit node that detects sets the ECN value to in binary 1, 1 code point, and then on egress, so if ECN in stack data MNA is exposed, and actually that might be interesting to discuss it with a proposal of preservation of hop by hop. What we envision that there could be multiple or several ECN MNA NASes. So then it takes the ECN value and copies it in the next closest ECN MNA ISD field. So for the preservation of ECN value. The node B, which is an egress for their MPLS domain, so it saves the ECN value from the NAS and combines it with IP value in ECN value in IP packet. So what we are planning to do next is align this document with the RFC 6040, which discusses their tunneling of IP packets and ECN in particular. Welcome comments and questions. And since it's pretty straightforward proposal, so consider the working group adoption. Thank you.
Thanks, Greg. This is Adrian as me. On the second slide, you asked a question. You said, can we do better? And then all of your slides described doing different, in other words, using M&A, but you haven't made a judgment on whether or not this is better.
Oh, well, again, So as of now, if we, well, as we looked at the state of art in MPLS, MPLS does not support ESCM. So from that point, what we can do with M&A is better than no supporting ECM in MPLS domain. Because again, that would be, because if we look for L4S, so from the L4S perspective, MPLS domain is undetectable congestion. So with M&A, whether it's ISD or PSD based, so we are exposing it to the conditions of possible congestion. So we believe that with help of M&A, yes, we can do better for MPLS domains.
Okay, anyone else? And then remarkably, we're done in time. Thanks to everybody for keeping to schedule. The chair's promised that next time round we'll ask for a larger slot and people won't be quite so rushed. Please check the notes. Matt will be updating them and according to the recording, but please check that anything you said is reflected. And we will see you in wherever it is we're going next, Montreal.
Thank you. Bye.
Oh, there's a bug. I was sharing the slides. I left the room and the slides remain shared. Well,
Hardly seems like a big deal.
no.
It did not disclose to the Epstein files.